Sir, good afternoon. Hello.
Yeah, good afternoon, Dr. Girish.
Sir, welcome back, sir. Welcome back.
Thank you.
Sir, we'll wait for a few minutes, then we'll start, sir.
Sure. Okay.
Thank you, sir. Thank you. Sir, hello. Mari, sir.
Yes.
Sir, can we start, sir?
Yeah.
Can we start?
Yes. Am I audible?
Afternoon to all the participants. I once again welcome you to this program. So, sir, please continue, sir. And over to you.
Okay. Yeah, good evening to everyone. I'm audible to everyone.
Yes, sir. Audible,
Okay.
sir. Audible.
So, yesterday, the continuation of analogid hands-on practice. Today, we are going to discuss about the modeling aspect. In the today sessions, two different kind of the models. I will explain how can we develop using analogid software. One is the binary logic model, and the second one will be the linear regressions model. So let us start our session today. So I request all the participants to open your Analogit software. So the applications will be there and enter your name and your institute name. There is no need of serial number. Click OK and it will lead to your Analogit window. Once you open, you start new project. Okay. So new project is started. You need to import the data. So yesterday I have a circulator, the data sheet. Go to the project, import variables. But before importing or entering our data, we should do the settings. As I told that default 222 rows will be there. In case your data is more than that, then it won't accommodate. Only 222 data points only it will incorporate. The remaining all will be eliminated. So to avoid those kind of the situations, you have to change what is the number of row of your particular problem. So anyway, our data sheet is carrying the 200 or 130 points. So there is a no issue, but still I will assume as a 500 as our dimension. Click OK. Okay. Once you defined the number of rows, go to import variable, click. So you find that Excel sheet, click open. So the data sheet is imported. Initially there is a no variables, but if you're clicking the plus, you can able to see all the variables. I request all the participant open your Analogit software, create a new project, then go to the project and do your settings. Once you done your settings, go to import. In the import, you can import your Excel sheet. So once the import is over, you can able to see the plus symbol near the variables. So all the variables are available here. Go to the data view, click the data view. So you can able to see all the datas. So here the cells are changed 500 rows. I have defined 500. Here you can able to see 500 rows. Basically our data carries only 130. So no issues. So yesterday sessions, we just discussed how descriptive statistic analysis we can perform. Today, I'm going to explain how to develop the binary logic model. Basically, our independent variable is interest. Okay, if you're opening that Excel sheet, whether they are interesting to shift e-bike or not. So that is the thing. So basically, if they are interested, they have rated as 1. Okay, so that is a 1 options. If they are not interested, they have rated as a 0. So totally 2 options. So that is in a binary options. So this is our y parameter. So we need to develop the model with respect to this y. So this is nothing but our dependent variable, and we might be having various independent variable like x1, x2, x3. So many questions we were asked during that questionnaire form. N number of questions we were asked. So what are the things we can incorporate that we are going to identify using that Enlogit software? That independent variable might be state. With respect to the state, it might be changing. With respect to the gender, it might be changing. With respect to age, it might be changing. So we have to identify which factors it is significantly influencing, and those factors incorporated in that utility function. So that is the things we are going to do. Basically, the binary logic model, it is in a probability. It is going to estimate the probability of whether they are willing to change that particular mode or not. Example, so this is the mode probability y equal to e power y divided by 1 plus e power y. So this is in a probability which we are going to estimate. This probability of y varies from 0 to 1. When we are applying and identifying the probability of y value, if it is less than 0.5, then the result will be 0. If it is greater than 0.5, then we need to consider 1. That means they are not willing to change and they are willing to change. This is a 2 inference we can get it from the final outcome of the binary logic model. So this is the probability equations of the binary logic model, and this y is considering as a utility function. So the utility function is nothing but this shape y is equal to beta 0 plus beta 1 into x1 plus beta 2 into x2 plus beta n into xn. So this x1, x2, x3 and all our independent variable, and the y is which we consider as a dependent variable. And all, this is the constant coefficients we need to estimate, and these are the estimators for the x1, estimates for the x2. All this beta 0, beta 1, beta 2 and all we are going to estimate by using that Enlogit software. Once all this parameter estimated, we are trying to develop these equations, and using that equations output we are applying here, and the final probability we are getting. So this is a step-by-step process we are going to infer from the binary logic outcome. Okay, I hope everybody is getting a clear knowledge. Our main motivation is to identify the people are rider are willing to change the e-bike or not. So it is in a binary data. So to develop the binary data, we are going to adopt the binary logic model, and this is the probability equations. In that probability equations, we have the utility function. So this is nothing but our utility function. The utility functions coefficients are going to estimate by using that Enlogit software. So let me explain the simple procedure of developing binary logic model. So go to the model. In the model, go to the binary choice. So here you have various type of model, but we are going to develop only the logic model. So binary logic model we are going to develop, because our data is binary data. If it is ranked data, then we may go for the probit analysis or the probit model. If it is a numbers, so it is in a discrete numbers, then we can go for the cumulative distributions, cumulative logistic regressions. So with respect to your dependent variable, you can choose which model you are going to utilize it. So or else you have to fit the distributions, and which distributions is fitting the most close to the data, that kind of the distributions model you can adopt for your research. So here you can click the logic model. It is a very simple process. You might be having your interest as the dependent variable, and one intercepts you have to consider. So again, this is your y, but we are going to consider state, gender, age, household size, qualification, occupations, working distance, working day, distance, expenditure, existing mode. So these are the factors we are trying to incorporate in your binary logic model, and we are going to see what the best outcome we are going to get. So here I'm going to develop the simple binary logic model, but in case if you want to choose with respect to the weightage, if you want to assign for the variables, that options also here available, and some other options also available, but our data is not coming under that particular assumptions. So that is the reasons I'm skipping that options, and output whatever the shape or the whatever things. If you need the marginal effect, so the marginal effect is nothing but it display if you're changing 1% of x1, making other x2 x3 are constant, what is the changes are happening in your y. The same time, all the independent variable are constant, only x2 we are changing 10% plus or minus. In that particular time, what is the changes in your dependent variable? So with respect to the changes on your independent variable, how the effects are happen in your dependent variable, that can be estimated using your marginal effect. So like that, the probabilities, if you want to display predictions under residuals, so whatever the output you require, so as per the requirement, you just click on it. So here I'm going to show the initial stage of how the output we are getting. So you can run, it will leads to your output window. So this is your output window. And from here we are getting your logit model outcomes from here. Logit, okay. Your LHS is nothing but your dependent variable is interest, and your RHS is other variable whatever we have considered. And this is the summary of your binary logic model analysis. Your dependent variable, it mentions interest. Weighting, we are not assigned any weightage. You have the number of observations, 130 observations, iterations. So the model is followed 30 iterations, then it is stopped. Then you can able to find the log likelihood of functions. Then the number of parameters, 11 parameters, it is considered in that equations. Then AIC value and the BIC value, restricted likelihood. So you might be having the likelihood and restricted likelihood. Then we can estimate what is the value. So you might be knowing -2. So likelihood plus or the minus restricted likelihood. So you can estimate the difference. Then the important parameter is R squared. So basically, I hope everybody aware that R squared value, how the developed model is giving the deviations from the predictions. But when it is coming to the logic model, we are considering the McFadden pseudo R square. Instead of simple R square, McFadden pseudo R square we are considering. Here the R square value is estimated with respect to the log likelihood function. So there is a two difference we are estimating, and we are projecting as a McFadden R square value. The two differences between the log likelihood value, which was estimated by considering the parameters, that means that independent variable, then the difference with a null, okay, null, when we are considering the null path of the maximum likelihood functions, what is that value? So that difference we have considered. The null is nothing but the constant, the one which we assign. So with respect to the one, what is the estimations? With respect to that, the difference is estimated. So the likelihood with respect to the variables and the null, the difference can be estimated, and how the deviations are happened between the predictions and the observations. According to that, the value can be estimated. So the basically the R square value we are widely using to justify how your model is accurately performing to estimate for the future conditions. It varies 0 to 1. So the value is which is close to 1, that is considering as a best and the fit model. Basically, if it is less than 0.3 or the 0.15, so it is considering as a poor performance. It is not with respect to the analysis what we have performed. The R squared is basically it is with respect to the variables what we have considered, how significantly it is giving the influencing for the dependent variable, or the number of the sample. So 130 sample is not sufficient to project that predictions model. In case if you are implementing small number of the sample, if you are performing the 1,000 number of the sample set, then there is a chance of improving and increasing that R square value. So that is the reasons it is replicating how accurately it is performing in the future forecasting by using your developed model. Then you have the chi-square value, you know the degree of freedom, and you know chi-square table. If you're comparing whether it is significantly influencing or not, that you can able to identify it. Then the p-values are there. So this is the overall summary of your binary logic model what we have developed. Next, we are moving to the important part. So the important part is nothing but your coefficients. As we told that you need to estimate beta 0, beta 1, beta 2 and all. So beta 0 is nothing but your constant, and our constant value is minus 69.735. Then state is x1. According to that x1, beta 0 is, this is the 1. x2, beta 2. Like that we have the 11 variables. So the 11 variables we have estimated what is the coefficients. Now what we are doing in the sense, we are going to check whether all the variables are significantly influencing in that particular model or not. So how we are going to check in the sense, we have the p-value. So with respect to the p-value, how the values are highly significant, according to that we can decide it. Basically, in this particular study, I am assuming the 95% confidence interval. So when it is coming to the 95% confidence interval, so it is allowed the 5%. Okay, that means your p-value should be less than 0.05. Or in case if you're considering 99% confidence interval, then your value should be less than 0.01. Then only the y and the considered x value significantly influencing each other. That means the xi is giving the significant contribution for developing that y value. So what we are going to do in the sense, we are going to check the p-value, but we have to see which are the value is coming under less than 0.05. If you are observing, there is no values is coming under the 0.05. So whatever the 11 parameters we have considered, so it is not giving the significant influencing for developing that particular equations. So in that case, what we have to do in the sense, yesterday I have explained that here we have to do in the trial and error basis modeling approach. So what next stage we are going to do in the sense, only 2 parameters we can consider, or else now we have considered 11 parameter. You can remove one state, you can remove, and with respect to the 10 parameters, you try to develop the model and we can check how the significant level is changed. So like that, you just remove and incorporate it. It's a kind of trial and error basis. You try to find which one will be the best or the suitable model for developing your equation. So this is in a way we can develop the binary logic model. In case before performing this analysis, you for performing the correlation test. Yesterday I mentioned that Pearson's correlations, Pearson's, Kendall, the both are there. So with respect to your data, from that correlation test, if you identified which are the factors are significantly influencing your y, so with respect to that x, you can develop your model. Example, if you developed the correlations matrix, the matrix you identify the distance, expenditure, existing mode. These 3 parameters only giving the significant impact means while developing your equations, you just incorporate only this 3 parameter instead of 11. So that is an alternative way how to find the significant factors and incorporate in your model. So hope everybody is getting the clear about how to get that coefficients value and how to check the significant value. If it is not significant, you just remove that factor and you perform the trial and error basis. So this is where we can get the results. And the another important parameters is success predictions rate. Okay, so here if you're coming down, you can able to see the success predictions table. This is one of the important statistical performance evaluations when we are trying to develop the logic model, not only binary, any logic model if you are developing, because it is a discrete data, we can perform the cross tab analysis. Yesterday we have seen, if you remember that, we have performed the cross tab analysis. So it is nothing but the cross tab analysis. We are trying to predict how it is deviate from the actual value. So you know what is the actual value and you know what is the predicted value, how it is different from the actual and the predictions, how successfully predicted, that we are going to estimate it. See, check, you can see this particular table. In that table, actual value is 0 and the predicted value also 0. So totally 96 are correctly predicted, 0. If you're seeing the 4, okay, in the field, 4 people are rated as a 0, but your developed model, it is predicted as a 1. So it is wrongly predicted. Getting my point? So which is a cross tab only success prediction table, which we are estimating. The actual value is 0. In your model also 96 parameters is successfully predicted, but only the 4 is predicted in wrongly as a 1. So the success rate is, we are estimating with respect to this 96. Then the second actual value is 1, but your model is predicted is 1, is only 4 prediction is successfully predicted. Remaining 26 is wrongly predicted and it is predicted as a 0. So this kind of the results we can get it from that table. So totally the successfully predicted is 96 plus 4. 100% data are successfully predicted and the remaining 30s are wrongly predicted. So your success predictions rate is 76.9 and failure prediction is 23.1. So this is an outcome we can get it. The same here you can able to see 76.93 success and 23 is your failure prediction. So this is an important significant parameters. Basically, when it is coming to the binary logic model, 2 factors is highly considered. One is McFadden R squared pseudo R squared value and the success predictions value. Your R squared value is supposed to be more than 0.3 in a acceptable condition. If it is going 0.5, it is good. If it is going 0.75, then it is a very good fit. So this is the inference we can get it from the R squared. And the same time, if you're performing the success prediction table, if it is going more than 80 or the 85 percentage, then definitely it is a highly success predictions rate when it is coming to the competition. At the same time, you can able to see, as I told that our model, everything is performed under the 95% confidence interval. So that is the threshold here. It is mentioned 0.5. Oh, sorry, this is not an confidence interval. This is a threshold. As I told that 0 to 1, if it is indicating, if it is less than 0.5, that is considered as a 0. If it is more than 0.5, that is considering as a 1. So that is the interpretation. The threshold value is considered as a 0.5 for estimating this success prediction table. So participant, so now we are in the important stage of developing the binary logic model. As we told that once you import your data, you go to the model, their binary choice option is there. There the logic option is there. If you're clicking your logic, you can able to see your dependent variable. Drop down functions will be there. Our dependent variable is interest and one is an intercept dependent variable. Maybe here I will consider only last 4 parameters. Maybe the distance, expenditure, existing mode, usage of the two-wheelers. Then you can run your program. And this is in a summary. You can able to see your dependent variable is your interest and other things are your independent variable. and you can get the clarity based on your log likelihood functions value, your McFadden pseudo R square value. See, if you are seeing that equations, now I did a trial and error basis method. If you are seeing the values of the p value, this is greater than 0.05, this is greater than 0.05, but this is less than 0.05, and this is greater than 0.05. So only this existing mode what they are using, that is giving the significant influencing on your decisions making process. So while developing your equations, so as of now, this is the one parameters giving the significant effect. So like that, when you're changing your parameters and you are playing with your trial and error basis method, you will get to know what parameter is exactly influencing in that particular equation. Here, if you are seeing the McFadden R squared is 0.05, so it is very less compared with the previous one. And your success predictions value is 76.6, same success predictions, 100 and the 30. So this is an outcome. You will get it from your binary logic model. And now here we are there to develop that utility equations. So maybe this is in your utility equations by considering this parameter y is equal to constant is minus 0.109. Minus 0.109 plus minus 0.004 minus 0.004 into x1, then minus some value into x2 minus some value into x3. So this is then your utility function which is got it from your nlogit software. Okay, in example future how you can apply, in the sense you might be knowing the x1 for your particular person, so this might be 4 or 5, and this value x2 might be 1, that x2 x3 might be 2 or 3. So you can apply what is that value and you know what is the coefficients, and finally you might be getting the y value. So y equal to, you might be getting the 21 example I'm telling. So you might be getting this particular value. So this value you are applying in your probability equations. Okay, so your probability equations you already know. The probability equations y is equal to e power 21 divided by 1 plus e power 21, and you will get what is that value. That value might be approximately 0.43, so which is less than 0.5. Then the probabilities we are assuming as a 0, which means that the person is not willing to change to the electrical vehicle. So this is an inference we can get it from your binary logic model. So audience, from the utility functions, you come to know what is that probability equations. Okay, so this is an output you are getting from your equations from the nlogit software. Using these coefficients, using all these coefficients, you can develop that utility functions. Once you develop that utility function, then apply that value in your probability equations. From that, you will get to know what is the probability of this particular problem. Okay, so this is a very simple process about the development of the binary logic model. So like that, depending upon your data, not only the binary logic, in case you have the order data 1, 2, 3, 4, 5, 5 order data is there. So you just adopt that probit model and you give your dependent variable, what is your dependent variable, and you assign what is your independent variable. then you will get in the same kind of the output. From that output, you try to develop your utility functions and the probability equation. So this is in a one part of model. As per today's discussions, we discussed. The second one, we are moving to the regressions equations, how we can develop simple linear regressions equation. So basically, what is your regressions equations? Everybody know that y is equal to mx plus c. So this is with respect to the single parameter. But when it is coming to the multi parameters, you see is your constant. Okay, then your c1 into x1 plus c2 into x2. So this is the things we are considering. So previously also with the utility function seems like same, but the parameter y is changing. This is in a continuous variable. Okay, so this is in a continuous variable. It might be n numbers. We can consider n. So it may varies from 0 to 100 or 0 to 2000. Even it might be minus 100 to plus 100. So the y is continuous variable. So we try to identify which factor is significantly influencing. So that factor should be incorporated in your model. So this is a linear regressions model. We will see how we can develop the linear regressions model in your equation. For an explanations and demo purpose, I'm using same interest as your dependent variable. But actually, we can't develop your interest as a dependent variable in your linear regressions equation because it is just a binary data. So the binary data should not be used. But for the procedures, for explaining the procedure, I'm assuming the same problem, how we can estimate that value that we can see. So the same data, go to the model, linear model, and you have a regression options. So participant, previously we have discussed binary logic model. Now we are moving to develop the linear regressions equations, particularly multiple linear regressions equation. For that purpose, go to model. In that model, linear models options. Under the linear models options, you have the options of regression. Click the regression. There you have a different kind of options. So here you can click what is your dependent variable interest. And one is your intercept, and you have the different kind of the variables. So you just click all the variables and you can click in your left side. So I'm not doing any options. I'm not performing any options. And same here also, you will get a different kind of output, like a display estimated the parameters covariations matrix. We can able to see predictions and the residuals of the individual value also we can able to see. So those kind of the output options, if you require, just you can click on it. So as of now, I'm not doing anything. So even autocorrelations also I'm not performing. I'm just running the program. We will see the output. See, this is an output we are getting from your linear regressions equation. So here the regressions outcome is starting. Your LHS, which is nothing but your dependent variable, is interest, and remaining all the parameters are considering as a independent variable. Since it is in linear regressions, which is assuming the normal distributions, you will get the value with respect to the normal distributions. And the model are developed and considered with respect to the 95% confidence interval. And you can see what is the mean standard deviations. And the important fitting parameter is R squared and the adjusted R squared. So the R squared is very, very low, 0.10, and the adjusted R squared is 0.031. So the R squared values are very low because the Y, what we have considered, it is not fulfilling the requirement or the assumptions. Next, what we have to do, listen, same as I told that there we have compared the value. So like that here we are comparing the p value. So the p value should be less than 0.05, then only it is giving the significant effect. At the same time, you have to see the t ratio. This is a student t test value. If it is 95, it should be greater than 1.96. If it is 99, then it should be greater than 2.26. So whatever the value is more than 1.96, that can be included in your final model. But here none of the parameters are getting the significant in your results. So that is the interpretations we can get it from here. So participant, now we have developed simple linear regression equations. So the main basics things we have considered the R square. We are getting an R square value. At the same time, we can have to incorporate only the significant variable. For that significant variable, here two parameters we are considering. One is the t value, another one is the p value. Since we are considering the 95% confidence interval, the p value should be less than 0.05 and the t value should be greater than 1.96. So this is an assumptions we have to make it, but it is not fulfilling the requirement. So what we have to do in the sense, basically what we do in the sense, we will do the trial and error basis binary logic model. I have explained that you can perform the trial and error basis method. So from that you can get it what will be the outcome. But linear regressions model, there is no need to worry about that to perform that particular trial and error basis method. For that simplifications, here we have the stepwise regressions method. So go to the model, go to the linear models, click the regressions. So in regression, click your dependent variable and all your independent variable. Go to the options. In that options you have a stepwise regressions equation. So you just enable the stepwise regressions equation. So what is the application of stepwise regressions in the sense the trial and error basis method automatically performed by using this particular options. There is no need to manually involve for performing this particular options. Once you click the stepwise and if you're running, the system itself automatically it is taking first it is taking all the 15 variables. Then the whatever first it is taking one, it is a forward method. So it is just incorporating the one variable and it is checking. If it then two parameters are included, then the three independent variable, four independent variable. So the systems is trial and error basis. It is incorporating, including, removing the variables automatically with respect to the significant value of p as well as the t. So once you enable the stepwise regressions, you just run your program. So this is in a first step. Another step it is going to take basically stage one it is performed, but still it want to take the another step. Give yes. Again it want to go for the another steps. Now the final model is ready. So from the bottom, you just to go to the top. Excuse. So step 3. So step 3 is the final one. So because step 3 stepwise regressions equation is developed, ordinary least square regressions techniques is followed and your model R squared is 0.3297 and adjusted R square value is 0.319. So it is giving a good fit. So it is giving a good fair directions since it is more than 0.3. And you can see this is your final model. Only two variables are incorporated in your equation. So policy 1C and the existing mode. So this is the two factors are significantly influencing and incorporated in your model. So this is an outcome we were getting from your stepwise regressions equation. Still, if you have a doubt, you just check your p value. So this is a p value 0.000, which is less than 0.05, 0.0288 less than 0.05, and t value is 7.36 more than 1.96, and the second value also more than 1.96. So we have not performed anything manually, trial and error basis method. The stepwise regressions techniques is enabled while performing the equation. The method itself performed all the analysis, and the final model is only incorporated the significant factors by considering the t value and the p value, and the respective coefficients we get it in an output. Also, we can check what is your R square value and the adjusted R square value. So basically we are getting nearly 0.3297. So this is an outcome of your equations, and you can develop your final equation. So this might be your y is equal to your constant. What is your constant? Minus 1.9 minus 0.19. Again your value, policy C1 0.356 plus 0.356 x1 plus minus 0.48 minus 0.48 x2. So this is your final linear regressions equations, which is considered under the 95% confidence interval, and the t value also consider, p value also consider for the 95%, and your adjusted r squared is approximately 0.329. Okay, so this is your r squared value. This is a way we can develop your linear regressions, multiple linear regression equations, and give the infer of your results. So when it is coming to the huge set of the data, so the software is giving the better performance. So if you are coming with so many number of variables xn, as well as the number of the data points, since we have considered only 130 samples, so it is very less. When it is coming to the transportation planning, basically minimum 600 samples, minimum 300 samples is sufficient with respect to the household size. But when it is coming to the planning and the other way of the modeling aspect, under minimum we used to consider the 600 sample. In case if you're going SEM model and all, you need the more than 1000 samples. So with respect to the sample size, your significant values are highly influencing. According to that, you will get it your better fitting of your model development. So here I'm concluding the first session of the today presentations, the Enlogit software hands-on practice, how we can develop the two different model. One is the binary logic model and another one will be the linear regressions equations, particularly multiple linear regressions. For developing the multiple linear regressions, how we have adopted stepwise regressions techniques to directly incorporate the only significant variables in the final model of your outcome. And binary logic model, we performed the trial and error basis method, and we try to identify and capture the significant factor which gives the better McFadden pseudo R squared and the success prediction table. So this is in a final outcome. So any doubt from the Enlogit, so we can discuss and then we can move to the another presentations. Since we have the very limited time, so I will explain the projects which we have done using the micro simulation software Vism. So first projects I will explain. If it is the time permit, we can go for the second project explanations also, how we can utilize the micro simulation software. So now Dr. Girish, now we can go for the discussions or the doubt of the Enlogit software, or I can continue the another session and finally we can go for the discussion. So any doubt from audience for Enlogit?
Sir, good evening, sir.
Yes, good evening.
Sir, regarding binary choice, that is modeling,
Yeah.
While going to take the dependent variable interest, I have taken some other independent variables.
Okay.
Next, After that one, what I have to do in the output window, sir? Shall I have to click the output window?
Yeah.
While running that, I am not getting the output, sir.
Actually, the other parameters which you have considered, it's supposed to be a binary data. Have you considered the binary data? It's supposed to be 0 or the 1. There's no more options.
Sir, I have taken interest as dependent variable.
Yes.
And the binary data means gender, this one, age, related sum. I have taken another for independent variables in the first window, main window.
Okay. See, now you can able to see the windows. So basically you are going to the model, binary choice options will be there.
Yes, sir.
Logit.
Yes,
and
sir.
the dependent variable, you can click your interest.
Yeah.
Then you have to give in intercept one. Basically you have to take it as your default one intercept. Okay.
Okay.
So it is enough for performing the null maximum likelihood functions. Then you may consider any 4 parameters and transfer in your left side.
Yes, sir.
And if you're running directly, it will leads to your output window.
So I need not go to the output window, sir, for that one.
Basically, if it is not going your output window, so here option is there. You can able to see this one, activate output window. If you click this button, so it will enable your output window. Sometimes if you're running, automatically it won't show the output window. So here I minimized, there is a no output window. If I click this one, the output window will come.
Click the output window, sir.
Yes.
Okay. Okay, sir. My doubt is over, sir. Clear.
Okay.
Thank you.
Okay, thank you, Nandini. Okay.
We will continue the next session, sir.
Yeah.
We will continue.
So the next presentation is related to the applications of micro simulation tool. Particularly, we are going to focus about the Vism software. So I'm just directly jumping to the problem what we are doing. Okay. So there is 2 projects here we are going to discuss. One is the development of conflict predictions model. So basically what we are doing in the sense conflict predictions model. The second will be the congestions. So these 2 we can see one by one. So the first one will be the development of conflict predictions model. Basically the conflict predictions model we are developing using that NLogit or the SPSS software. It is a kind of your regressions equations only. So this is the predictions and this might be your equations beta 1 beta 2 into C1 so x1 so beta 2 into x2. So this is the final outcome of your conflict predictions model, but the conflict is depend on the various variable real world variable problems as well as the data like speed, volume. So all these variables is considering as a x1 x2. At the same time the y is also it is in a conflict which can be able to predict from the field. Sometimes you might not be able to predict from the field. So we are playing with all the things we are playing with your real world scenario. So we can't collect that real world data. So according to that, we can't develop the model. So you might be performing the videographic survey. From that, you can extract the number of the parameters. But if the sample size is not sufficient, it is highly difficult to justify your data. So in that case, what we are doing in the sense, we are trying to develop some small amount of the data from the field. Using that field data, we are developing some of the simulation model. So once the simulations model is ready, we are running with respect to the different scenarios. From that, we are extracting whatever the dependent and the independent variables are required for your model development. Using that simulated data, we are developing this final equation. So this is in a working flow, how we are developing the predictions model by using the micro simulation software Vism. Okay. So basically for our study purpose, we have selected 6 study locations. Particularly, we are focusing about the uncontrolled intersections. So this is an uncontrolled intersections. There is no signal are exist in that particular 7 location. Basically what we are doing in the sense, two type of the data we are collecting from the field. One is videographic data, the second will be the geometric characteristics. To develop the model on the Vism software, you need the geometric data. So all this geometric characteristics we used to collect from the field. So once you finalize the locations, we can collect the 1 hour or the 2 hours video as well as the geometric characteristic. So this is the road width which we collected from the field, as well as we can able to identify what is the conflict area for this particular study in that location. So likewise, so this is a geometric characteristic in the 2 directions. Okay, it is in 2 directions. So this is a major road and this is a minor road. Also, what is the shoulder width? If the median is there, you need to consider the median also. So once the geometric characteristics collected, then we went for the parallelly we conducted the videographic survey. Basically, we have collected the video during the peak hours. So we have considered the 8:30 to 10:30 as a peak hour. Once you collected the videographic data, we have the IITB traffic data extracted software. It is an open source software. Using that software, we have extracted the various parameters like a traffic volume with respect to the classification of vehicle and the traffic speed of the all the vehicle. So basically for the Visms, what we are doing to the sense, it is same actually. So this same locations, this kind of the same locations we are going to model in your Vism software, and we have collected the real world volume as well as the speed, the same input we are giving, and we are trying to replicate that actual scenario in your software. So instead of field, further considerations of the field, the same real world scenario we are bringing to your Vism software. So that is the motivations of our first model, model calibrations as well as the validation. To replicate that actual situations, what we are doing in the sense, exact geometric characteristics we are designing in your software, whatever the geometric data we have collected. At the same time, the same volume, same speed we are trying to project in your Vism software. In case if it is not matching, if some errors are there, the 1000 volumes are extracted or the collected. If we are generating the 900 or the 800, the error are high. To normalize that error, we have to calibrate the model by modifying the various factors. Then the calibration is over, your developed Vism model is performing and replicating the actual condition of your field in your simulation software. So with that motivations, we are giving the 3 major input. One is the traffic volume, okay, turning traffic, and the vehicle compositions percentage. So this is the first one we are doing with respect to the volume. Second, with respect to the speed. So speed also we have to calibrate. We have to match with the field data. Third one will be the travel time. So the travel time also match with your predicted, that means your simulated as well as your feed value. So this 3 you have to compare, and if more error you have to calibrate, again you have to reduce that comparisons error, which give the close indications with your field value. So that is the things we are doing in the Vism software. So basically this is the classified peak hour volume which extracted from the videographic survey. So 2 hours video collected, and we classified auto, bus, car, two-wheeler, LCV and the HCV. And these are the different movements. Totally 12 movements we have observed. It is in a 4-leg intersection. So all this movement, how the individual compositions volumes are there. Because in input of Visms, we need the total volume as well as each vehicle type, what is that volume for the each moments are required. So this kind of the data are required for giving that input of your Vism software. So once you extracted the data, next we are going for the speed extraction. The same as I told that IITB data extracted software will be there. You can extract the speed of the all the vehicle for the all the directions, like previously what I have shown with respect to the directions, with respect to the vehicle classifications, we extracted the speed value. So this is in a two-wheeler, first 15 to 20 km/h, how many vehicles are crossed. So this is the things we have prepared, but initially we have extracted with respect to the time 8:30 to 10:30. From that we have estimated the 85th percentile speed. So you might be having the number of the speed, you have to plot the cumulative plot. S curve you have to plot. From that you try to identify what is the percentage of the 85th percentile. According to that, what is your speed that can be estimated. Or else yesterday we have discussed, you can give your input data percentile, we can extract. Okay, descriptive statistic analysis, we have seen how to collect the output as a percentile. So using that ANLogic software also, we can able to estimate what is the 85th percentile speed of that particular locations. Once the field data is extracted, travel time also we can estimate. So you know what is your origin from the video, and you know what is your destinations. It might be the 25 meter or the 34-meter trap length. So what is the entering, existing, and what is the travel time. So the travel time also can be estimated using the IITB data extractor software. Okay, so basically what we are doing in the sense, we are trying to do the model volume and speeds. We are giving us an input, we are trying to check and calibrate. We are giving the priority rules, again we are calibrating and validating. So once all this process is over, the output are extracted TRG format that can be given to the SSAM software. So this is another objective, but in the today, so the only first objective I'm going to explain how the WISDOM model is developed. So basically in the WISDOM software, so this is a way we can develop your route network. So you know what is the geometric width of the all the intersections. This is in a major road and minor road. We have extracted the details from the field geometric characteristics. The same scenarios we are giving, and all the moments, the totally 12 moments we have observed from the field. All the 12 moments you have to explain in your WISDOM software how the movements are happening. So using your geometric characteristics, you can plot your intersection. Once the intersection is designed as per the field data, you give the movement of the vehicle. So 12 moments, if you're observed, you try to give all the moments. So this is the first part we are doing. Second, we have to give the traffic volume and the vehicle compositions. So we have extracted the traffic volume, and you have the options to give the traffic volume and the compositions of the each leg. So totally 4 legs are there. So 4 legs will be there, and each leg you might be having the different kind of the input window. So in that input window, car, two-wheeler, LCV, HCV, everything will be there. With respect to the leg, you can define. Even with respect to the movement, you can define. So the traffic volume, you can give it as an input with respect to the vehicle compositions. That will be your second step. Third, the speed distributions. As I told that the speed distributions table is there. What is your 85th percentile you can give, or else you might be plotted your S type of the curve. That is also you can give it as an your input area. So this is in a second input. The final one will be the conflict area and the priority rules. Since it is a non or unsynchronized intersections, you might be observed the conflict area from your videographic data. So those conflict areas are we can able to define with respect to the link and the movement. So you might be observe the gap between the two vehicles with respect to the gap threshold, how it is safety or the unsafe or the danger. So those kind of the classifications we can give, and your conflict areas and the priority rules also defined. So first priority is given for the major road, that to throw movement or the right turning movement. So the priority rules also you can give it as an input. Once the input is given, you run your simulations and you will get the desired output. So in the WISDOM, you can able to get the 3D kind of the output or the 2D also, and the whatever output you require that you can explain in your output window also. So before performing the simulations, you just explain you need the travel time, delay, speed, generated volume, So whatever the data you require from that Visum software, you just click enable that particular things, then you can run your simulation, then you automatically you will get it your output that can be saved in your Excel sheet format. So this is in a working flow, how we are giving input and how we are getting an output in your Visum software, particularly for this conflict study. So the next slide, it is showing that the comparisons of the simulated speed with observed speed in that particular intersection. So I am not segregated with respect to the moment. Okay, so this is blue color indicating the simulated speed and orange indicating the field observed speed. Okay, in that both values are compared. So if the errors are more than the identified or the given threshold value, we need to go for that calibrations process. So basically this is a little bit micro level. We are explained how this one arm is there, how the movements are there, and how the volumes we are giving us an input. And this is the same speed input how we have a given. And this is a routing, how much, how totally 12 moment, how it is occupied with respect to the lane wise. That is also you can explain. So you might be having the two lane. In the two lanes are giving first for the throw moment, or one lane for the throw moment, one lane for the left and right turning moment. Those kind of the routing decisions also you can give in your Visum software. This is in a conflict area and the priority rules given, and the same result in the another view. So in the Visum software, to get the videos, you might be having more than 12 positions. You can make it your camera. You can set which angle you want to make your camera. You can keep your camera here. You can give the camera options here, keep the camera options here. So we can define which angle you need your output video. So that is also visible in your Visum software. So the Visum is generating the wonderful output which can give the better inference and the results for the users. So far we have seen the working flow. Just on a snapshot I have explained. If I'm taking to the software, so it may take 2 to 3 days demonstrations or the hands-on practice if you want to work on some software. So that is simplifications. I just explained with a snapshot how the step-by-step process we can perform for giving the input and output, and what are the ways we can get your output. Now I'm moving to the major technical part is calibration. As I told, that three major parameters we are comparing to replicate that actual field presentations in your simulation model. Traffic volume has to match, speed has to match, average travel time has to match. If it is not matching, again you have to calibrate your equations, calibrate your model, then you can go for the validation. So basically, traffic volume, we are considering the GEH statistic value. For the average speed, we are using map. Travel time, we are using the map value. So let's see one by one how it is there for our particular conflict model. So this is nothing but GEH statistics, which is comparing between the simulated traffic volume and the real world traffic volume. Okay. So it is the most widely used indicator for checking the goodness of fit of your micro simulation model. So whatever the simulations, particularly micro simulation studies, if you're referring, you can able to see the GEH statistics value. The value is less than less than 5, then the traffic flows, whatever extract simulated, that is a good fit. If it is lies between the 5 to 10, it indicates that it require the further investigation. In case if it is more than 10, the traffic flow values cannot be considered to be a good fit. It is mandatory to calibrate your data. So this kind of the inference we can get it from your GEH value, how it is varies or actually fit your simulated traffic volume with real world traffic volume. And this is in a 6 study locations which we consider for our study purpose. All 6 locations models are modeled in your Visum, in our Visum software, and we have compared your observed and this simulated value. If we are seeing all these values are less than 5, So there's a no need of any changes. But this only one location is greater than 10% of error, GH error. So it means that this particular locations need to be calibrated. So in that case, what we have to do, you have to perform the various simulations runs you have to do, and we have to close fit with your data to avoid that maximum error. So here I'm not explaining anything with respect to the calibrations, with respect to the volume. Second, I can move to the speed. For the speed and the travel time, we are considering map value, mean absolute percentage error. So the percentage is less than 10%, then it is considerable for your model, which is close fit the simulations with your field value. So this is an observed average speed and the simulated, and this is an absolute percentage error. So if you're seeing almost all the locations, if you're seeing all, so the overall percentage error we can able to see is 6.46. So this is the value we can get it, map value for that particular locations. So it is less than 10%, then there's a no need of modifications or the calibrations of speed. If it is greater than 10, then we need to perform for the calibrations. And this is the graphical representations of the variations of your average simulated and the observed speed. The final one will be the travel time. So as I told that from the Vism software, you can able to get the travel time. So the travel time measurements, you have the options. You just to check from which point to which point. Example, this is a 1 point and this is another point. So you need the travel time between these 2 points. So you can define what is your starting point and what is your ending point. So according to that, during the simulations, you can estimate your travel time that can be compared with your feed value. So this is an observed travel time and this is your simulated travel time. And here also we are using the mean absolute percentage error. And if you're seeing that error, it is more than 10%. It is at 27.13, which is more than 10%. Then there is a need to perform the calibrations. Okay. For calibrations, what basically we are doing in the sense, 3 factors we are redesigning and we are doing the simulations again. So we have checked the 3 parameters, volume, speed, and travel time. And we have the GH statistic value and the map value. The map value for the travel time is greater than 10%. So that is the reasons we are going for the calibration. We are considering standstill distance, which is available in the software, then the headway time, desired decelerations value. So these values are changing. We are changing, and again we are performing. Then we are checking what will be the map value. Then again, if it is not less than 10%, again the trial and error process we are performing. So to calibrate the travel time, basically we are considering these 3 parameters. So I'm not going to do much in the technical aspect, so it may take some time tedious. So just directly I'm going to the results. So once you modified all those 3 values, headway, standstill, as well as your desired decelerations. So this is in a final output we are getting. Your map value is almost near to the 10.58. So still the accuracy levels are not reached up to the level because the HCD, if you are seeing, it is going 16%, 11%, 19%. So again, you have to modify all those 3 parameters. This is the first set of changes we got it. The second set of changes also you have to perform and you try to identify what will be the closest or the lesser map value. Then we finalize that model is performing the best fit for that particular location. So once all this 3 calibration is over, you can finalize your developed simulations model on the Vism more enough to project for the future scenario. So in that future scenarios, you just do whatever you want to make it as a various scenario analysis. So you can increase the volume, how the conflicts are happening. If you are decreasing the volume, how conflicts are changing. Second, the conflicts are happening if you want to extend the road with lane width. Initially, we know what is your geometric field characteristics. If you're increasing your geometric characteristic as a 3 meter extra, so how the performance are changing, that analysis also you can get it in an output. Still, if your studies require the flyover, so there is an options of constructing the flyover in Vism software. The major road you can construct the flyover and you change your movement of the vehicle, and you again you can you perform this same analysis and you will get it what will be the safety of that particular locations by providing the flyover. Or else, as I told, that input you can give with respect to the vehicle classification. Because of HCV, the more accidents are happening. So what we can do, we can only restrict that HCV movement. You emit that HCV movement from your input data and you can again simulate that particular model. Then you come to know what will be the conflict ratio at that particular location. So this kind of various trial and error or the scenario analysis we can perform, and we can conclude that that is almost equal to the real world scenario, because before performing all the scenario analysis we have calibrated our simulation model by considering the various parameters such as the volume, speed and the travel time. So this is the conclusions we can get it from your Vism software. So this is one example I have given with respect to how to model, calibrate and identify the conflict. So likewise, we can perform the various analysis also. That another example is signalized intersection. So you can insert the signalized intersection and you know what is the field signal time, what is the field volume, field travel time, as well as the speed. All these values are we are comparing with the simulated as well as the actual value, and we are using all the statistical GS statistics and the map value, and you are calibrating that signal time. Once the calibration is over, your simulation model is equal to the field value. Then you can play with your signal time. You change your signal time 120 to 150 or the 180. So like that, you perform your analysis and you try to calculate the delay value, and where you are getting that optimized value, that signal time is considering it's a optimized signal time. So like that, you can perform the various analysis with respect to the signal also. The important another application is parking study also. You can perform what is the parking index, parking accumulations. If you're constructing the 3-layer parking, 3-level parking, 4-level parking, so all this analysis is feasible in your Vism simulation software. But whatever the analysis you are doing before the model scenario analysis, first the calibration is mandatory task. So you must perform that calibrations. That is changing with respect to applications of your study. If you are considering parking, then the calibration parameter is different. Conflict study, your parameter is different. So if you're studying about the congestions, so your parameter is different. If you're studying about the lane changing behavior, then the calibration parameters are different. So with respect to your research problem, you identify what are the factors you are going to calibrate it, and then you can finalize it. But most possibly the travel time, travel speed and the travel volume will be the default for the all the calibrations process. So here I'm concluding the one applications of Vism software. How can we use for model calibrations as well as the validations with respect to the conflict model development. Once all this simulations is done, you can extract the conflict value, speed, respect to the traffic volume and all. X will 1, 2, 3 will be there, and the Y is nothing but your conflict. All these details you can give it as an input to your enlogit software, and you can develop the model. Basically, it is a count data, conflict, number of the conflict. So you can use the Bison's model or the negative binomial model, which is already possible in your enlogit software. So here I am concluding. I would like to thank AICTE for sponsoring this workshop. Also, I would like to thank Dr. Girish for giving this opportunity. Now the floor is open for the discussions related to the Enlogit as well as the Vism, or any doubts related to the transportation engineering.
Thank you so much, sir, Dr. Mari, sir. Yeah. We request the participants to post your questions in the chat box. Then we can close the session. This hands-on is really difficult, but though you are able to deliver us very effective in an effective manner, sir. Thank you very much, sir, Dr. Mari, sir.
Yes, yeah. I'm feeling
Because
very
I
difficult to give the hands-on practice
yes,
on
yes, I
online
know.
mode, whether you are following, whether you are practicing, or what kind of error you are getting. So highly, it is a difficult task in online.
Online, yes. But few participants are able to get some that results. In the previous workshop we did together, that SPSS tool also. We got a great feedback also to that
Yes.
hands-on.
Yeah, it went very successful. I hope this is also we gone through the successful. But my objective is to cover the two software. But yeah, practically when we are going, it definitely it is highly difficult. Even the good thing is there we are recording and circulating the videos to the participant.
Then
Definitely that is a good directions we are doing. Yes, this question is we already seen. Is there any options for two dependent variable selection? So in Enlogit software, there is a no possibility, not Enlogit, there is a no possibilities of choosing the two dependent variable of any modeling aspect. So dependent variable is an alone, it is in a single. Okay, independent only n number of the data will be there. Again, you have to do as a what we can see. Two-stage process, even nested logic also. I have told that yesterday two options will be there, public as well as the private. Under the public, two options are there, buses or the train. So like the two-stage performance, you can perform it in case if it is require your model architect. But directly we can't perform by using any software.
Sir, good evening, sir.
Yes, good evening, Nazir.
Sir, regarding this one, I visited Dubai three years back, sir.
Okay.
My friend was a consultant there. He's having own office there. While we are traveling to financial district, that is Burj Khalifa is there. Well, I mean that location. I observed a radar is there. Radar.
Okay.
He told me that radar detects if anybody crosses the speed limit or violates that one, immediately he will be penalized through SMS or through an alert.
Yeah.
That system is there in India, sir? Radar system?
Yes. So basically, that what you have observed, it is a kind of the application of intelligent transportation systems. So without involving any monitoring manpower, directly it capturing and it is connecting with the license plate number and the what we can say the penalties directly detected. But so far in India, we have not adopted that kind of the system, but the same kind of the architect we have adopted for our toll collections. So last December we have implemented RFID. The
Yes.
working mechanism is same for that RFID. Automatically it is detecting. It is your what we can say your toll collections from your barcode to your database to license plate number, license plate to your account. Then your gate is automatically opening. So that same architects is applied for the RFID toll collections, but the penalty so far I have not observed or come through in India as of my knowledge.
Okay, sir. Another question, sir. Another question. Regarding the Enlogit software, actually, what we are getting the output, sir, the mean the standard deviation of the conflict, sir. What is the main objective of that usage of that software, sir? I'm not getting that one.
Basically, to estimate the coefficients of your independent variable. So basically what we are trying to develop the mathematical equations, you might be having some base set of data. When it is coming to the after 20 years or the 50 years, or if you're changing your x1 or x2, what will be that y that you have to predict from that actual equations. By using that baseline data, we are trying which one is close equal result is giving for that dependent variable by the combination of the independent variable. In that case, you need to estimate the coefficients like a beta 0, beta 1, beta 2 and all these coefficients has to be significant at some confidence interval 95 or the 99. Then only we can indicate that it is close replicate to your y value. So that is the reason the first steps we are checking how closely it is replicating your dependent variable. Once the similarity is confirmed, from that we try to estimate what is that coefficients. Once you estimated that coefficients, your equation is ready, and any imaginary sessions or the any future forecasting, you can apply that value and you can estimate your y value. The y value might not be feasible to predict in your future.
Yeah,
In
yeah.
that case, we can use that equations.
Okay.
Example, some simple example I'm telling that actually you are a male, okay, driver, your age is 30, okay, if you're driving to that particular road, what is the probability of uh, meet the accident with another vehicle? So
Okay.
this kind of that practical issues we can't play on the field. So for replicating that same scenarios, this mathematical representation is giving how probabilities are there to conflict with another vehicle. So those kind of the scenarios we are trying to capture from that coefficients what we estimated.
Okay, sir. Understood, sir. Thank you.
So some light on the junction problem, how to consider the presence of traffic island in the junctions. So yes, when it is coming to the junction, definitely the islands are playing the major role, particularly when we are talking about the pedestrian. There is a island is there that is highly avoiding the conflict between the pedestrian and the vehicle. So that is a one kind of the research scope we can study how the islands are giving the proper safety for the pedestrian. With respect to the volume, what will be that particular island with the 2 meter or the 3 meter, 5 meter. So those kind of the optimization problems we can perform and we can identify what will be the optimized width of that particular pedestrian. So like that, we can perform for the traffic also. In case if you're providing the channel sessions, if you want to provide the free left turning by providing the channel sessions, so how the movements are changing, how the turning conflicts are reduced by providing those channelizations. So those kind of the safety related studies we can perform with respect to the traffic island or the pedestrian island or the any channelizations at signalized or unsignalized intersections also. So this is the some research scope we can perform at a junction, particularly with respect to the traffic island.
Oh,
So
thank you,
in
sir.
Mumbai, yes, somebody is floated. In Mumbai, we are getting each challan if anyone is not following the speed limit or disobeying the traffic signal too. Yeah, probably it might be there in Mumbai. I'm not explored, but when I'm talking about the Tiruchirappalli city, which where I'm residing, here also over speedings are there. It is not monitored by any radar or the drone option. If the police was occupying that particular road stretch, he might be having that radar gun, so he's shooting that vehicles and he's getting that what is the vehicle speed as well as that license plate number. According to that, it is linked with the database server. So one of my students also received the same kind of that issues, okay, and that over speeding limit is observed by that police who is monitoring that particular locations, and he received that e-challan. Also the money is detected automatically from that linked number.
Thank you, sir. Hello.
Yes, yes.
Yeah. Now, regarding the junction island issue,
Yeah.
the physical presence of a roundabout, is it possible to input to the model? That's the actual doubt I had. That's all.
Actually, in the mathematical approach, we can't apply in that physical island. But when we are talking about the vism, so you just modify your island. Okay, what will be the radius, entry and exit with all this modeling trial and error basis we can perform in the vism model. From that output, whatever you are getting, according to that output, if you are developing the mathematical equations, that will give the better clarity or the better results. So Vism is one of the best options if you want to really play with the actual geometric characteristics.
Thank you.
Yes, sir. So any other queries from the audience? So any doubts, Dr. Girish, or we can close the session?
Then we will close the session. Maybe since it's over, the questionnaire part is over.
Yes,
Well,
yeah.
Dr. Mari sir, I am very happy. Once again, we are meeting in this platform. This is our nth time, the journey of these webinars. Thank you for all the time for your support and continuously being collaborating with us, with our institute. The civil engineering department and Sri Vishnu Engineering College for Women is obviously thanking you, sir, for your fabulous, fantastic presentation, the hands-on experience. I could see you because I even attended a lot of webinars from various institutes. People are not giving a hands-on, but we are able to give it, and you are one of the best in giving hands-on experience, though we have a lot of difficulties in online platform. Thank you very much, sir. And these videos we are recording and keeping in YouTube also. Maybe a lot of people, the participants, the faculty or scholars or students will be definitely useful for this. And yeah, thanking you for accepting this, and we look forward for your future collaboration too.
Yeah. Thank you,
Thank you, sir.
Dr. Girish, and thanks for all the participants. Okay, then I'm leaving the session, Dr. Girish.
All right, sir. Yes, sir. Please carry on, sir. Thank you.
Thank you. Thank you once again, everyone. Stay safe. See you.
I thank all the participants for your cooperation, and we came to the end of the session, and we are closing in few minutes. And tomorrow, one session will be left over for this entire program. We meet at 10:30. Tomorrow, we are planning the session to start at 10:30, 10:30 to maximum before 12. We are going to wind up with the valediction. So the assessment link also will be posted in tomorrow's session.